So hi guys, today I'm going to do the video tutorial for the chapter 5. So I'm going to find the activity to help you to give you guide or help you in answering this activity. So this tutorial will be a guide and help for you while answering the activity in chapter 5. So this activity in chapter 5, it has a Mac and LCC. So as you know this, for the Mac, um, so for the Mac, so for the Mac sublayer, so the Mac sublayer, it is a act of Mac so the Mac sublayer, it is a act of act as an interface between the logical link control or the LLC, then so this done an acts interface between the logical and link local control. So as you can see, so it is an acts in interface between the logical link control. So the Mac sublayer, it emulates a full duplex logical communication channel in multi-point network. So this channel may provide unicast, multicast, or broadcast communication service. So for the Mac sublayer, so the Mac sublayer, as you can see in this, the Mac sublayer protocol. So for you to give and have an example for the Mac sublayer, so as you can see in this Ethernet Mac sublayer protocol, we have the preamble, destination address, source address, type, data, pad, and checksum. So now for the LLC sublayer, so the LLC sublayer, so for the LLC sublayer, so the LLC sublayer acts as an interface between the media and access. So from the it inter in acts as an interface between the media access control sublayer and the network layer. So for you again to have an idea for the LLC, we have so I'm going to search for the LLC sublayer. So this the LLC sublayer or logical link control. So as you can see, there are IEEE. So in the IEEE 802 reference, so the model computer networking, the logical link control data communication protocol layer is the upper sublayer of the data link layer of 7-layer OSI model. So that's for the logical. So the answer would be control the network interface card through software driver. So this one, it is going to be LCC, works with upper layer to add application information for delivery of data. Higher level protocols will be LCC again, and controls with hardware to support bandwidth requirements and check errors the the bits sent and received. LCC and the Mac sublayer and controls access to the media through signaling and physical media standard requirements. It's gonna be the MAC and support Ethernet technology by using CSMA-CD or CSMA-CA, which going to be the MAC again and remains relative independent of physical equipment, which is going to be DLCC. So let's check for this one. So this guide is for this activity, but let's go find and so for this activity, as you can see, we have the Ethernet frame fields. So as this field, we have it's like on the so let's search for the Ethernet switch field. The Ethernet frame field name. So as you can see, like what on that, let's see have so the Ethernet frame fields name. So as you can see, we have this one or the Ethernet frame format is the preamble, um, ST, SFT, which is the preamble, which has 7 bytes, and the SFD, which is 1 byte, destination address, which has 6 bytes, source address, which has 6 bytes, length, which has 2 bytes, data, which has 46 to 15 bytes, and CRC, which has 4 bytes. So, going to answer this one. So, as you can see, we have the 802 header and data. So, to search for the 802 header and data, 802.2 header and data. So yeah, so um, so so for the preamble, so the preamble it has 7 bytes and the start frame delimiter or the SFD are also called start of frame, which has 1 byte. So field used for so the SFD, which has 1 byte. Then for the preamble, which has 7 byte, So fields are used for synchronize between the sending and receiving devices. So I think which is going to be the preamble is notifies destination to get ready for a new frame, and the start frame delimiter is the synchronizing sending and receiving from the frame delivery. So um so for the source address and the destination address. So the source address it has um 6 byte. So the source address has 6 bytes. It identifies the frame originating NIC or NIC or interface it must be a unicast address. So for the source, it's going to be the frame's originating NIC or interface MAC address. And then for the type, so the type byte, has 2 byte. Um, the, then for the type, it detects error in the Ethernet frame. Then for the um, FCS or the frame check sequence, for the type it is the this one. It describes the which higher layer protocol has been used. For the detects error in Ethernet frame, it is the frame check sequence because of detect errors. And it has a 4 bytes, which is the FCS. It has 4 bytes. And then for the destination address, it will be the assist a host determining if the frame is received from the word itself received. And the 802.2 header data, it is uses pad to increase this frame fields to at least 64 bits. So yeah, the 802.2 HD has a 64 at least at least 64 bits. So that's that's for the um chapter 5 tutorial. So in this, I hope that this guide will help you on answering this chapter. So thank you guys for watching.